Welcome friends. In this session, I'm going to present you a new circuit called daylight alarm. Most of us use an alarm quite often to wake up at a specific time. To make this work, you need to fix a specific time for it. These types of alarms are useful when you need to wake up at any odd hour, either to catch up an early morning bus or to catch up a class which is at 4 o'clock. However, there are many people out there like me who do not need a specific time to wake up, but they need an easy to use alarm which can help them wake up as the sun rises. That is maybe at 6 o'clock, or maybe at 5:30 to 6 o'clock, or 6:15 or 6:10. That doesn't matter whether I wake up at 6 o'clock or 6:10. I don't have any much work to do then. So in such a case, I think a daylight alarm, that means a circuit which wakes you up depending on the daylight, will be a very good idea. So in this session, let me present that circuit to you. Here is the circuit. The circuit consists of a 555 timer in a stable mode, an LDR, a speaker, and a few other switches. This is the 555 timer circuit, which is connected in a stable mode, and this is the LDR. Here is the speaker and a few other capacitors and resistors, etc. And we shall also see the operation of the circuit soon. Now let me show you the LDR. LDR functions as follows. Its resistance decreases with increasing light intensity falling on it, and its resistance increases with decreasing light intensity. That means if in the daytime it offers a very low resistance because light falls on it, and when it is dark it offers a very high resistance. That is the property of this. And now we shall see the 555 timer. This is the pin diagram of the 555 timer. It looks like this, and this is the pin diagram of 555 timer. Pin 1 is 0 volt, pin 2 is trigger, pin 3 is output, pin 4 is reset, and leaving all these things, I mean, pin 5 is control, 6 is threshold, 7 discharge, and 8 is VCC, that is a high voltage. Now in this configuration we are assembling this 555 timer in the stable mode and using the reset pin to control the timer. That means we are making the reset pin to become low when when it is when it is dark, and the reset pin will go high when it is not dark. Let me show you how we have done this. Yes, in this circuit, here the LDR is connected to LDR. This pin 4 is connected to the combination of LDR and a resistor, a variable resistor. It is connected to high, that is the 9 volts, to LDR, to a 5 kilo ohm variable resistor, to ground. This is a potential divider arrangement. Now we shall take two cases. First case is when it is dark. When it is dark, as I've told you, an LDR offers a very high resistance. That means maybe it offers a 1 mega ohm resistance, for example. Then if you apply the potential divider rule here, from here it is 9 volts, 9 volts into 1 mega ohm divided by 1 mega ohm plus 5 volts. What would be the voltage drop here? It would be almost near to 9 volts. That means most of the voltage is getting dropped here, and at this point we have a low voltage, that is, which is nearly equal to the 0 voltage. So at dark, when it is dark, the pin 4 of the 555 timer is 0, I mean is given a low voltage. That is why the 555 timer will go off. That is a property of the 555 timer. The reset pin, if it is low, then the 555 timer will go off, and if the reset pin, which is the fourth pin, if it is given a high voltage, then the 555 timer will run in its normal mode. Now the normal mode is the stable multivibrator mode, so it will run in a stable multivibrator mode when the pin 4 is given high. Now let us take our second case, that is when there is light present. That means when it is a daytime. In the daytime, what happens is the LDR offers relatively low resistance, very low resistance, maybe around 1 kilo ohm or 2 kilo ohm, like that. In that case, what happens is majority of the voltage drops across 5 kilo ohm variable resistor and not across LDR. Thereby, at this point, we have a high voltage. If you apply the voltage divider rule again, 9 volts into 5 kilo ohm divided by, we shall assume it as 1 kilo ohm, 9 volts into 5 kilo ohm divided by 1 kilo ohm plus 5 kilo ohm. What would be the value of voltage drop here? It would be very near to 9 volts. That is, it is a high voltage. Thereby, the 555 timer will run in the astable mode when it is not dark. That means when sun rises. As it runs in the stable mode, the pin 3, which is the output pin, will give a square wave output, and this square wave output of definite frequency is fed to the speaker. That means the speaker vibrates with that fixed frequency given by the astable multivibrator, and the frequency with which the astable multivibrator gives the output, generates the output, is determined by these resistors R1, R2, and C1. By changing these parameters, you can change the frequency of the stable multivibrator. And in general, it is recommended to change the value of R1, keeping the value of R2 and C1 constants. I hope you understood the working principle of the circuit, and also you can make it at your home and try it out. Thank you.